So here we have an interesting question about Pacman. And what we're wanting to find here using a triple integral in spherical coordinates, we want to find the volume inside his mouth. And so we're told that Pacman is a sphere of radius 2 and that his mouth angle here is pi over 6. And I think that there are two natural ways to try and set up this triple integral. One is to take Pacman and kind of turn him over a little bit, kind of lay him on his side so that his mouth is going straight up and down, kind of from side to side. Another way is to just slap some XYZ coordinates on him like this and try and set it up that way. It turns out that this first way to do it is what's going to allow us to use spherical coordinates nicely, and the second way that might seem more natural actually has a fatal flaw. So let's see what those look like. So the first way, if we kind of turn Pacman on its side, we get a picture kind of like this. And so the integral in spherical coordinates looks like this. We want to, once we've set theta and we want to move phi all the way from 0 to pi. 0 for phi, right, starts us straight up along the z-axis. Moving that to pi is going to move us all the way down to the negative z-axis. And if we let rho move from 0 to 2 for each of those angles, right, at least here, like in this first cut, theta equals 0, where we're pointing along the x-axis direction, right, we'll trace out that side of Pacman's mouth. And then if we allow this to happen for all the thetas from 0 to pi over 6, that'll take this and kind of swing it out by that pi over 6 angle, and we'll get everything kind of in between and end up figuring out the volume of Pacman's open mouth there. We can kind of see that happening as well with this interactive. Give it a sec. Here we go. And so here, if here rho is set to 3, it doesn't really matter. If we take phi and swing that down all the way to pi, right, we can see we're indeed tracing out kind of this one side of Pacman's mouth. And if we take theta and swing that over to pi over 6 or so, we can see that if we imagine the three-dimensional solid this is sweeping out, yes, this is going to be handing us exactly the shape of Pacman's open mouth that we want to compute. Okay, so let's look at the other way. The other way is to just slap our coordinates on Pacman as he looks in the picture and try and work it out like this. And I think the natural way to set this up is, well, let's let rho go from 0 to 2, phi go from, here I have Pacman's bottom kind of lip parallel to the x-axis. And so, well, if this angle here is going to be pi over 6, then that means phi, which up on the positive z-axis is 0, needs to start at pi over 3, and then sweeping out pi over 6, it would end at pi over 2 and 4. These are for phi. And that sweeps out the idea here is that this sweeps out the angle of pi over 6 that we would like. And then arranged like this, we want theta to move from negative pi over 2 right along here, negative pi over 2, all the way up to pi over 2, so that we kind of get the same right region, right directions for his mouth. The issue for this, though, is that moving rho from 0 to 2, I claim, is only what we want to do in this very special situation when our theta is 0 and we're pointing out kind of in this direction along the x-axis. In that case, then sweeping out from 0 to 2 for the phis that we want from pi over 3 to pi over 6 gives us this chunk that we wanted to see. But notice if we change our theta, if we swing this a little bit, let's say all the way up to pi over 2. So now we're looking straight along the y-axis here. Notice Pacman's mouth is actually shut along the y-axis, right? That's one of the creases of his mouth. And so we don't want to use these angles anymore. We would actually only want to use phi equals pi over 2 along the y-axis. Right? If we do our angles from pi over 3 to pi over 6, notice we are tracing out a whole chunk of Pacman's face that we don't want to. And so it's this issue that depending on our theta, our phis are going to change. And perhaps, as I think about it now, maybe the 0 to 2, maybe that's okay. I think the main issue here is that the phis we want to use depend on what theta we're looking at. And so we'd have to do this whole crazy analysis to figure out, okay, well, what phis do we want to use depending on what theta, get phi as a function of theta, and it'd just be a mess. We can also see kind of this issue happening with the interactive. Let me bring that up. If we, let's see, bring our phi up to, something like, the pi over 3, and we imagine starting theta at 0 and sweeping it up to pi in this case. Actually, let's see if we can just do what we wanted. Let's just match it with our picture. All right, and now we're looking at actually this kind of blank space underneath, right? That's going to be what our instructions sweep out as we sweep theta. And notice that three-dimensional region we are tracing out with this kind of a lower slice does not look like Pacman's mouth. And that's the issue with trying to set it up in that second way. We don't really get the shape of Pacman's mouth that we want to see.